Welcome to Turf Wars, where Harvard engineering students compete to see whose remote-controlled vehicle will take the crown. Vehicles have to pick up debris, return it, and park. Our robots have to be fabricated from stock parts, assembled in lab, and use concepts that we learn from class. The competition's fierce, but we're fierce too. The robot has to not get stuck on the turf, so there's a minimum ground clearance there. The robot also has to fit within size requirements. It should have enough power and speed to be able to score many points, and its intake-outtake has a capacity that, with specified torque, will allow us to actually pick up the items. We used a Pew matrix to decide which robot design we were going to go with. Concept number 1 was the one we went with because its 4-bar linkage and its active intake would allow picking up items to be very smooth. Concept number 2 failed because its drivetrain would drag, and therefore it would cause a lot of problems, including friction. It could also snap off. Concept number 3 could only carry one item at a time because of its claw gripper. Therefore, it was very inefficient, and we didn't go with it. We fabricated the drivetrain out of acrylic using laser cutting. We also 3D printed miscellaneous parts, including a PLA mold for casting our silicon paddle wheel intake. We used horizontal Bandsaw machines, lathes, and drill machines in order to fabricate metal parts. We also used a CAM machine for a wax mold. We assembled everything inside of the lab, including the use of various hand tools. We used engineering principles by validating that our robot would work with physical calculations before we worked on the gears, motors, etc. While fabricating this robot was fun, we did learn a lot of lessons, including being prepared for minor redesigns. We had to redesign our active intakes from small pinwheels to a large paddle wheel in order to be more efficient.